Today we're going to be looking at what types of series converge and diverge. So as an intro to that, thinking back to last week, with geometric series, we looked at the sums of geometric series, and the only time that those converged was if r was between -1 and 1, or you could think about that as the absolute value of r is less than 1. So you're thinking about fractions like 1/2, -2/3, things that are between -1 and 1. And when that was the case for your r, you could find the sum using this formula. However, with arithmetic series, those never converge because you're either going to keep adding numbers or keep subtracting numbers forever, and you're not going to get close to a number. Some other series that you popularly will see are these two series that we'll solidify later. But normally in class, we would compare these as a group and talk about what conclusions you guys have. But looking through these, I started writing out the first few terms. So I plugged in a 1 for the denominator, plugged in a 2, and then I kind of showed it going to the 10th term. So as you go, you can see the bottom is getting bigger, but not that quickly. Compared to this series, as I plug in a 1 for the k, and then a 2, and a 3, and then eventually a 10, and I get 1/100, this 1/100 is a lot smaller than 1/10. Ooh, not sure what that was, but a 1/100 is a lot smaller than 1/10. So we're eventually going to prove that this series is converging fast enough that it actually does converge. It's getting close to 0 fast enough, whereas this series, although it's getting smaller, isn't doing it quickly enough, so this one is actually going to diverge. The special name we have for a series that's 1/k or 1/n is called the harmonic series, and we're going to look at that series as we go along, but this one, just in case I ever refer to harmonic series, that's going to be the 1/n or 1/k. So the harmonic series is always going to diverge. The 1/k² is always going to converge. And we're going to show different tests for that today. So in general, infinite series that we know converge are geometric series where r is less than 1. So those are the types where you can find the sum. The absolute value of r is less than 1. And then also this one that we just talked about. And we'll have a test for that later. But both of these are just ones you should know always converge. And then as far as diverging go, geometric series that we know diverge are when r is greater than 1, or if it's like a negative number or less than -1. That one you can't find the sum, so it's going to diverge. And then all non-zero arithmetic series will also diverge. And then this harmonic series we just talked about will also diverge, and we'll have a test for that today as well. So as you work through your lessons today, we're going to look at three different tests, and we'll find out ways to prove whether series converge or diverge.